Here we're going to perform a circuit simulation. For that, we'll be using a software called Configurator Software Hub, which is basically a product from Renesas. All right, let's open it up. Once you open it, you'll see this window appear on your screen. Now, go to the Develop tab, and here you'll find the MCU family numbers listed. You can select any one of them from here. For example, let's pick this one. Okay, now it'll show up on the front screen, here. You need to set the voltage limitation and in what range your voltage will be. Then later you'll see that we must set two voltage sources in the circuit, one for the input side and one for the output side. After that, click on Apply, and then OK. Here we have our pins. These are input pins. And over here we've got output pins. If you want to add any component, just scroll down and click on Applied OK. Now we have our component added. That's a NAND gate. It has both inputs and outputs which we can set. To set the input, just look here. I've done it like this. Wherever a connection can be made, you'll see the lines turn green. Lock it in place there and leave it. Now, it's showing us that the input selection has changed. That means the digital input is set. We need to set two inputs, so let's connect one more pin here. All right. Now this pin is also set as a digital input. Let's connect it with the voltage source as well. Now what I want is, a circuit where the output of one NAND gate works as the input for the second NAND gate. So, let's go back. Take another 2-bit component. Double-click on it, and from here set it as a NAND gate. Click Apply, and there you go. Another NAND gate is ready. Now we'll connect its input with the output of the first NAND gate. To complete the second input, we'll connect it with another pin here. So now both inputs are getting voltage, meaning both inputs are 1, but we also want zeros, right? For combinations like 0, 1, or 1, 0. So what we'll do is, we'll attach another ground component with one of the inputs to make it 0. You can also copy it, or just add a new one directly from here, okay? Now we've connected this one with ground, so it's getting input 0, while the other one is still getting input 1. Now I want the final output to appear on pin 14, so I'll attach the output there. When we debug this, we'll click on Software Simulation, then OK, and then click on Start. You'll see a pop-up appear. Just click Start Simulation. Now, notice something. It's showing voltage simulation, but not for any input or output signals yet. That's because, for output, we haven't added any probe. For inputs, it automatically added one, but for outputs, we have to do it manually. So, let's go ahead and add a probe on the output pin. All right, done! Now let's run the simulation again. You can see now, the output on pin 14 is also showing in the simulation. So what's happening here? We've got a NAND gate, and both its inputs are 1 because both are connected with voltage. When both inputs are 1, the NAND gate's output becomes 0. Now, that 0 goes into the second NAND gate as input, and the other input of that gate is also connected to ground, which means that's 0 too. So for a NAND gate, when both inputs are 0.0, the output becomes 1. That means the output on pin 14 is 1, or high. When it's 0, that means it's low. See? Right now, the output is showing high, meaning 1. So that's how we've made a simple circuit using NAND. Like the same way. If you want an input to be 0, just connect it to ground, and if you want it to be 1, connect it with voltage. That's it.